I'm Zachary Cartwright. This is Water in Food.
As you develop the favorites or the winners, you can take those and you can run them on the VSA, and you can get a head start or an early look into what your shelf life is going to be. 45 hours running on a VSA right up front, it's faster.
Water has been called the luck of the planet by Daniel Boorstin, and its impact and significance are evident everywhere in the foods that we eat. Every year, billions of dollars are spent by food manufacturers to move water in and out of food products. As a food scientist, I am on a mission to understand how this can be done better. Welcome to another episode of Water in Food. Today I'm joined by Aaron Denzler at Thorne Research. Hey Aaron, how's it going? Thanks for joining us.
It's going great today. Thanks for having me.
Yeah, of course. I'm excited to talk to you and discuss water in your products and how you've been able to start applying isotherms to your research. But to start off with, why don't you tell us a little bit about your role at Thorne and how long you've been there?
My current role at Thorne is research scientist 2, specifically for the Effusio product. And I'm working with Thorne on my 5th year currently.
And what brought you to Thorne? What is your background in and how did you end up there?
My background is in science all the way through. Graduated from Montana State University in Billings with a Bachelor of Science in Biology. And during my time there, it all kicked off with an internship program where I got into R&D and product development right out of the gate before I graduated. And it's all been flowing in this direction ever since then. What the key thing that brought me to Thorne was my interest in the way that they operate and the products that they provide. It fit well into my goals as an individual and as a professional.
And how did you find Thorne? Did you find them online or through LinkedIn or what ultimately brought you there?
It's a fun story. The short version is it was sheer luck, and it was a job fair sign that they had out in front of their manufacturing facility in Sandpoint, Idaho. As I was touring through the area, I was living in Spokane at the time, and I just stopped in and asked them when it was, and lo and behold, it was a few days later. I attended, and the rest is history.
I hadn't realized that you lived so close to the Meter headquarters, so I'm glad that you're familiar with this area. And what makes you excited to go to work now? What gets you out of bed every day, and what do you look forward to doing at work?
I'm proud to be a part of Thorne and what they're doing. So that makes that first step all that easier every day. And then my deep-seated interest in science and data and making decisions based on data is another key to success for me. So being able to show up here on campus and be happy to be here, and then be able to work doing something that I can see as the best fit for me. The two combos, it's nice.
And what types of products are you working on now? What products does Thorne specialize in, and what makes these products different from your competitors?
Sure. Thorne manufactures nutritional supplements. We're very deep-seated in health technology. We're a science-driven wellness company. That's who we are. We manufacture encapsulated products, ready-to-mix powders, and importantly, very close to my heart would be our Effusio product line, which are dissolvable beverage discs. What really separates us from our competitors is our quality and purity. We've made decisions along the road to eliminate and reduce the use of unneeded excipients and fillers, and we are genuinely interested in the outcome and well-being of our customers.
And as you work through that R&D process and eliminate excipients and really focus on your products, how is water important to that process, and how are you measuring water?
Water is a very important factor for us. As you eliminate certain excipients and fillers, the job becomes more difficult throughout the manufacturing process. It can become more difficult with shelf life. It complicates things, and that's a task that we're willing to take on. But to do that, we need to have data, and we need to know what is water doing to our product. How is it lasting inside of our packaging components? What kind of steps do we need to take during the manufacturing process to to succeed. It's a big deal.
And as you start to collect that data and look at water, how are moisture sorption isotherms a part of that process? And when did you start using isotherms in your R&D team?
Sure. Our experience with Meter Group was kicked off by a recommendation from a coworker that knew of Meter, and that's how that ball got rolling. Is we determined that this product, or the VSA specifically, was going to be able to give us the ability to analyze how our samples would react in a controlled environment with a set temperature when you introduce water vapor. What happens there? How does it absorb the water? What happens when it absorbs water? And that allows us to determine critical water activities. It helps us determine shelf life. We can predict shelf life as long as we complete the calculations. It can give me a glass transition point, so I can look and identify a trouble spot within our product, and I can make data-driven decisions based on the output that we're getting.
So it sounds like you're using isotherms to do a lot more than maybe just a single water activity measurement or a single moisture content measurement. It's giving you that entire picture. And from my understanding, you recently used isotherms to prove that a packaging material wasn't necessarily living up to its specs. And I was wondering if you could talk about that experience a little bit more.
Certainly. So this is a new product. This is from our Effusio line. This is the first time we've worked with this, and we haven't found anyone else out there who is working with it. So it was from the ground up. So every step forward, there were challenges, and the challenge that you brought up was the packaging. At first, we didn't know it was the packaging. All we knew is that this product was sticking or adhering itself to the interior of our pouch material, which is completely unexpected. That's not supposed to happen. We went through, of course, all the checklists. We looked at formulation, we looked at process. We started drilling down, and nothing was adding up. And by that mean the data wasn't telling us that we had a problem with any of those checkpoints. So then I started measuring the water content of these discs that were adhering to the interior of the pouch, and I observed that we were increasing in our percent moisture in these products as the increase in sticking occurred. So that didn't make sense because you have a spec on your packaging, and boy, those that's something that you got to be able to hang your hat on or lean up against in troubled times. And after running our product on the VSA and comparing it to observation, I was able to predict that with that particular packaging component and our particular product being tested, our shelf life should be at least 10 times longer than what we were observing with the shelf life in that package. That spurred us to send that pouch material out for vapor barrier testing, and lo and behold, it came back and it said exactly what the shelf life predictor said, which was the spec was not accurate, and we had far too much vapor transfer happening. Our product was acting like a desiccant in its packaging component. So the VSA knocked it. It knocked it out of the park. The VSA told us exactly what happened.
So just to clarify, the packaging company was telling you that packaging material had a specific water vapor transmission rate, and when you used that in the packaging calculations in the moisture analysis toolkit software, it was telling you that you should hit a shelf life, but what you were seeing in actuality was that you were having that stickiness to the inside of your packaging, and it wasn't even close. And so when you went and had another third party test that packaging material, it was different from what that packaging company had told you. And you wouldn't have understood that if you didn't do the isotherm analysis on that vapor sorption analyzer. Is that correct?
That's correct. It would have been had we reached out to that third party to test the barrier, it would have been it wouldn't have been driven by the data that the VSA gave us. It would have been us just looking into it, simply looking into it. And that's not something normal to just check in on a packaging specification. That's why we rely on specifications. But the data was so strong from the VSA, it made the decision to test the packaging material a no-brainer. It was instant.
Yeah, I would be curious to know how often this happens. How many times a packaging company might not quite live up to what it's actually saying. And at least with the isotherm, this is a way to test that, and then also a way to pinpoint the packaging water vapor transmission rate that you actually need. What other types of challenges have you been using isotherms for from the R&D side of things?
Well, what I've been using it for recently is to add valuable data to our shelf life predictions. uh, the more data points that you have, the better your decisions are. So I've been running a lot of our encapsulated products and our ready to mix powders through there, adding that data set to our current data for shelf life calculations, which are extremely important as we grow and have our products residing in different regions, and for potentially longer durations or shorter durations. It's all about the environment and how it can impact the product in which it resides.
So let's go back just a little bit. I want to talk about those glass transition points and why they're important to your team. You're using that isotherm to pinpoint where the glass transition point is. But then once you have that information, what are you doing with it?
Sure. One example is that seeing a glass transition point and correlating that to analytical data as far as the activity, and label claim that we absolutely stand by. You can see a decline in activities of raw materials ingredients when that glass transition happens. So we can stress a product utilizing the glass transition model, and take analytical data, and we can see a shift or a change. So we know what to avoid, and we know that we can believe in that glass transition point, and how it can help us say throughout its shelf life, this is a problem area that we need to avoid. Otherwise, our product isn't what we set out to make it be.
How well is that glass transition point that you're determining with the isotherm? How well does that line up with what you're seeing in the real world?
So I work so very closely with this with our dissolvable beverage discs. I mean, that is the department in which I reside. I see these every day, so much observation, so much data stacked up. And when I take a glass transition, and I model it, and I look at the product I'm working with, I can see that glass transition in action. I can physically stress that product. And when I reach that correlating point with the glass transition, I can see a negative change in my product. And so that allows us to set a boundary and say, this is the no-go line. If we exceed this amount, this water activity or this moisture content, we're in trouble. So we will do what we need to do to never reach that boundary.
And what is the business value of being able to have this information early in the R&D process before mass producing one of your products?
Well, in the world of iterating through formulas and developing what we would call a prospective master formula, there's a whole stack of those iterations. And as you develop the favorites or the winners, you can take those and you can run them on the VSA, and you can get a head start or an early look into what your shelf life is going to be like, and that is a money saver right there. I mean, that's you cannot do that without implementing accelerated conditions in an environmental chamber, and then coupling that with analytical data. That's common practice all over the world for that. This is another set of valuable data that can add to that to make those decisions viable, or just stacking data to make it an even more educated decision.
Yeah, it sounds like by having that isotherm data, you have that competitive edge because it may allow you to maybe be the first to market with new products or reduce your R&D costs. I think that those isotherms also work somewhat as an insurance plan because you're able to avoid any problems before they even happen. Is there anything else that you might add to that list?
To go back to the early discovery of issues, I did leave something out, and 45 hours running on a VSA is far shorter than 6 weeks in an accelerated environmental chamber. So we can get an early peak if something is just plain not going to work. There's no sense in having that elongated time. So it's right up front. It's faster.
And like you said, any traditional shelf life test or even an accelerated test is going to take much longer than anyone really wants to wait. And so even though this test is still maybe a 2-day test, it's still the fastest way to get these types of insights. Even a traditional laboratory isotherm or an isotherm using a DVS, a dynamic vapor absorption method, those can also take a long time. And you're using that DDI, the dynamic dew point isotherm. That's a patented method that was produced by Meter Group. Maybe you can talk a little bit about that specific method and how it's been helpful to you. And have you had the chance to look at these other types of methods and apply them to your products as well?
Right now, I am thoroughly enamored with the DDI method. That's what I'm using for everything currently. What it does for me is it gives me the isotherm model that I can easily recognize now that I've had practice. It gives me, it graphs out a curve that I can read now, and I use that model to plug it into the numerous modules that the software comes with. Example, we touched on the glass transition point. I can use that. I can use it to predict my shelf life. I can use it to predict what kind of packaging I may need to use to keep a product stable if I've set a boundary. Um, it it's been great learning about it, and the challenges that I've faced thus far. I've been able to hop on calls with yourself, for example, and I've improved or I've gained the knowledge on interpreting the data, which has been vital. Once you learn how to read these things, you can really take off pretty quickly. It's been a pleasurable experience so far.
Yeah, it's been fun to watch you transition from kind of an isotherm novice to really an isotherm application specialist like myself. And what would you say has been the most rewarding part of that experience?
Oh man, data. I mean I it is so incredibly stressful in the R&D world, and it's really just not a thing that should happen is having to make decisions without some data to help to drive that. Observations, they're part of science, but you got to put that with data, or else you're going to end up spinning your wheels. You might end up down a dead end. It's this data that the VSA has given us has been very valuable in improvement, which is something that we do here every day. Is we want to improve and continue to thrive.
And Aaron, one of the pushbacks that I see from other R&D teams when they're thinking about isotherms, sometimes I think they're a little frightened at having to learn this new method and sit down and even though they're getting all of these new insights into their products, it does take some time to learn how to create an isotherm and how to analyze it and how to do the calculations that you've talked about today. What are some of the challenges that you had with isotherms, and how have you been able to overcome these challenges?
The support from Meter Group has been there to help me through these challenges. One specifically was interpreting some of the more difficult or some of the irregular isotherm models. And I recently had to put in a request with you yourself. I just couldn't get data that I wanted, but it's math, and so I know that it was something that I was doing or I wasn't providing the right values to the equation, and we went ahead and we modeled the isotherm in a different way, and we set our beginning and critical water activities where they needed to be to get a more accurate output on our shelf life calculation, and then it worked. So it's another another tool that I have that I can use, as a solo, or just on my own, let's say. You can take the training wheels off, and I don't have to check in with you on it anymore, because I know what I'm looking at, and I know how to manipulate the data.
Sure. And one thing I do want to mention here is that Meter Group really views this as a partnership. Anytime that we sell a vapor absorption analyzer and help a team start to understand isotherms, we do have to teach you how to walk before you run. But it's a rewarding experience for, I think, both sides or both companies. And so that is something that I personally enjoy doing, working with people like you and showing them, if the math isn't working or if the model doesn't make sense, then we sit down and we really look at what's going on so that in the future you're able to do this yourself. From here, I just want to talk about what's new with Thorne. Are there any product launches that you want our listeners to be aware of, and where can listeners find your products?
No, the easiest answer is our Effusio product line. It's in my job title. I'm very proud of this product line. I believe in it. It's a dissolvable beverage disc, and we do have two currently available through Thorne.com. You can learn more at Effusio.com, and the best place to order any Thorne products is at Thorne.com.
And I want to finish with this. The last time that we spoke, you were getting ready to go fishing, and I'm just curious if you had any luck when you went out.
Oh, it was a great day. Yes, it was. We had some sunshine, and we had a good day on the water. It was the near shore or inshore red drum fishing. I recommend it to anyone and everyone who enjoys fishing.
Did you do any fishing when you were in this area close to Spokane?
Oh, absolutely. Yep. The St. Joe River is probably one of my favorite all-time fishing locations on the planet.
Aaron, I just want to say thank you for your time today. I've really enjoyed talking to you about isotherms and learning how you're using this. And again, it's been great to watch you go from the isotherm novice to really applying these almost every day that you go to work. So thanks again for being on this episode.
Yeah, thank you very much, and thank you for all your help and all of the problems you've helped me solve to this point.
I'm Zachary Cartwright. This is Water and Food. Find this podcast on Apple iTunes, Spotify, or wherever you listen to podcasts.